say welcome to the Frontiers of Science lecture. But before I start, how many of you are going to the Science March on Saturday? Okay, if you don't know about it, please go. It starts at 3 p.m. And I've written down the instructions right here. If you want to come up later, write them down. But it starts at City Creek Park and goes to the state capitol. It starts at 3 o'clock. I think there's speeches at 4 o'clock. Is that correct? And hang out until 5 and make a lot of noise, okay? So show up. It's important. So this is our last lecture in the series this year. And again, it's the 50th anniversary. If you flip your brochure over, you can read a little bit about the history of this seminar series, which is the oldest one at the university. And we've had some pretty interesting talks this year. How many went to all 6? I know I did. So it's been a really interesting seminar series, I have to tell you. The talks range from the effects of population growth to microbiology of evolution, why birds matter. We had a talk on a very snowy evening about nuclear weapons in North Korea, which unfortunately is becoming a more current and important issue as we speak. The last one was on harvesting energy from the sun and an artificial leaf, which was a fascinating talk. We're starting to arrange speakers for next year. I know we've got 3 lined up. One is going to talk about critical materials, one of our own alumni. And we've got 2 lined up from the Smithsonian, one of which has been on assignment to the State Department for the last year, trying to preserve the treasures in the Middle East from destruction by ISIS and the Taliban. And that'll be a very interesting presentation, I'm sure. I think that one's in March. So tonight, you get a real treat. You're going to get to listen to one of our own, Dr. Frank Brown, a distinguished professor and past dean of our college. Still dean a little bit, though. Still a little bit. And I have to tell you, so when I came here for my interview, I got to meet Frank in his office. And when I walked in, almost immediately the phone answered. And I said, go ahead and take that. And he immediately started to speak in Swahili. And I knew at that point that I was in deep, deep trouble. There's no way I can fill Frank's footsteps. He's I kind of think of him as our Percy Fawcett. Do you guys know who Percy Fawcett is? He was a great British explorer who, I don't know, rumors are that he may have eventually been eaten in the jungles in Amazon, so hopefully that won't happen to Frank, but we're very happy to have him here. But he was this big, tall, lanky guy whose life was dedicated to understanding the Amazon, and Frank's life has been dedicated to understanding Africa, and tonight you'll hear a little bit about it. So I'm going to let Turi Serling, another one of our distinguished professors, take the mic from me and tell you probably a couple stories about Frank, I'm guessing. So,
I'm actually not going to tell many stories about Frank, but I think one of the themes that'll come through Frank's talk is some aspects of serendipity and how just some chance sort of changes the total direction. And so, for instance, with Frank and my relationship is exactly that way. I had a summer job with the Anaconda Company, which no longer exists, but they used to have an office out near the airport. And Frank was at an office here. We were working in the same field area. So I called him up one day and said, oh, I'm Turi Serling, and you're Frank Brown. Why don't we get together to talk about some stuff? We've been talking a lot for the last 41 years. And I found in Frank a very collaborative person, and I'm sure I wouldn't have applied for the job at University of Utah had I not known Frank personally. And I wouldn't have met my wife if I hadn't come to University of Utah. So one of the things that you may have noticed when you're coming in is a whole series of slides of a lot of plants from Africa. Frank may say something about those, I'm not sure. I know he's always, fascinated with plants. It's one of the experiences I have. He said, oh, you remember the, Jatropha plant that was next to the, the little stream with the metamorphic rocks with, some mineral in it when we drove that road in 1981? The the one we drove underneath the bush, and you were driving, and you put the thorn through my eye, that one, you know. Anyway, so one of his loves is plants. Another of his loves is languages, and this won't come through in his talk, I'm sure, the many languages that he's spent a lot of time working on, and just the love of people in the environment and the surroundings in general. So the one story I will tell is what happens if you are with Frank in a small village, say the village of Lodwar or town of Lodwar in Kenya. And in all of these little towns, you're always besieged by children and other people who, come, they like something. You're a white guy, so you're obviously rich and can, help them out. 50 shillings. Can I have 50 shillings? And what Frank will do is bend over and pick up a plastic bag, give it to the child and say, if you come back and this is completely full of discarded plastic bags, I'll give you 50 shillings. And it's his way of teaching a little lesson and helping clean up the environment. So with that, I'll just introduce Frank, my long-term colleague, who will be telling you about his research on understanding the geology of East Africa, especially as it pertains to early human evolution.
Enter a password.
I don't know, computer. Is that?
Yeah, that's yours. Okay. That's a good one to start off with. Okay. Well, this evening what I want to do is sort of tell you a story about a chunk of the world. It's called the Omo-Turkana Basin. It's situated on the border of Kenya and Ethiopia. I'll show you some maps in a minute. It's a place that I first went to in 1966 by myself, and I think about sending a student from here to someplace like the dean would go absolutely nuts if I sent a student to the middle of Congo by himself. Even today, when you have satellite phones and various things, I wrote 3 letters to my mother home. I mailed them about a month apart the first year. 2 of them had arrived before I got back. The other one arrived after I got back. Communications have changed God bless it. This is a different computer. Where do you start it? Damn it. Where is it? There it is.
So I think if you push,
There it is.
there we go.
There we go. Okay. We are we are set, I think. I've called this a treasury of history because the Turkana Basin, a lot of what happens in science is serendipitous. You're doing one thing, you're prevented from doing that, and you look around to see what else there is to do, and you find all sorts of things. It's particularly true where things aren't very well known, and that was certainly the case here in East Africa. All right. So the Turkana Basin is better work. This is Lake Turkana, this long lake here. It's about 200 kilometers long. All right, and I'll show you in a bit. It's a low area. It's located in northernmost Kenya, southernmost Ethiopia, and then you see that this is a bit of Sudan sticking out here. That's a chunk of the world called the Lme Triangle. It's been administered by Kenya since 1925. We actually worked in there this January. I think it will eventually become part of Kenya, and this border will be shot straight across there. it has become difficult now because they've found oil in Turkana. And there's oil in southern Sudan, so nobody wants to give up any acreage, all right? The lakes coming down here, this is the Afar Depression, where Saudi Arabia moved away from Africa. There's the Red Sea here, the Gulf of Aden. And these lakes mark the position of the East African Rift Valley. You see it's not very well defined in the Turkana region, but it's spreading very, very rapidly there, okay? So these are my objectives. They're to note how singular events can change research and why politics matter. And the reason politics matter is that you can only work where you are allowed to work. I want to tell you a little bit of the history of the work in this region of East Africa and try to give you some idea of the vast size of the area. If I had known in 1966 how big this project would be in simple square kilometers or square miles, I probably never would have started. I want to touch on the human diversity of the region. This is important because you don't want to, you know, we have a difficult time as white people telling black people apart. But you don't want to walk up to a Mercy and say, Ejok. No, you want to say Chali, because otherwise you might get shot, okay? So I want to explain how we've woven together the geology of the region and dated its fossils, and to note the importance of the region for the history of humankind and many, many sorts of mammals. We have a fantastic collection of mammals. Well, this is the singular event. Anyone know, what was big in 1959? Anyone know? Xerox was introduced. Pantyhose was introduced. Barbie doll was introduced. And Mary Leakey found Zinjanthropus at Olduvai Gorge in 1959. And Lewis, her husband, he was out there. He was sick in camp when she found it, but he got well very quickly. And he got in touch with Garnis Curtis, my old prof, one of my old profs, and Garnis dated the things at 1.75 million years. Now, when I was in school, the oldest man could be was about 1 million years. And then this upstart from Berkeley and comes up and said, no, this is at least 1.75 million years ago. Well, that set off research in East Africa in a big way, because the Leakeys had worked for 30 years at Olduvai. They saw stone tools, but they'd found no early hominids. All of those in Africa came from South Africa, all right? Well, the place that I went is there. That's where Lake Turkana is. That map was published in 1886. So the Europeans didn't even know it existed, all right? Then this guy, Taliki Fonsek, was having a dalliance with the princes of the Austro-Hungarian Empire, and Rudolf said, you know, buddy, you might just take a walk. And so he took a walk from Nairobi and found Lake Turkana. He went with this guy, von Hernal. And von Hernal took absolutely fantastic notes, wrote them up in the Denkschrift der Wissenschaftlichen Akademie Wien, and they're still good reading. He was an incredible observer. Well, these guys heard about it, went across from Brugge de Bozat was interested in paleontology. He brought a paleontologist from the French National Museum with him, and Bozat never made it across Africa. He got as far as the Congo and died from probably malaria and typhoid. It was a combination of a couple diseases. But Brump got back with his notebooks. And so this old guy, who I had the pleasure of working with, tremendous guy, Camille Ehrenberg, in 1932 went there and brought back tons of fossils that were rather like the ones at Olduvai. And this guy, who read everything, Clark Howell, is the guy that sent me to the Omo Valley in 1966. And what he wanted to do, Clark was amazing in many ways, encyclopedic. He had read all of this French stuff, and he said, these are like the Olduvai fossils. If they have early man at Olduvai, it should be there in the Turkana Basin, north of the lake, in the Shungora Formation that Camille Ehrenberg had worked on earlier, right? So that's sort of a really brief history of that. A funny story about Clark, he was so avid to get there. He went up in 1959 during the time of the Mau Mau in Kenya. And he was worried that he might get shot, so he told me, He took a pistol with him, but he had never tried it. And on the way back, he thought one day, oh, I ought to go out and try this thing. And he had the wrong sized ammunition, which is, that's the way. Oh, geez. That's how good scientists are at taking care of themselves, all right? So major points, all right? The basin is immense. I said vast, and then I changed it to immense last night. The region's culturally diverse. It contains a fascinating geological record, but there are long hiatuses, times where we don't have record, and that's something I've been chasing for the last 30 years anyway. It's of interest to all sorts of people. You can read. I don't need to read it all. The Oligocene and Miocene strata, these are something that we had never planned to work on. These are things that go between about 30 and 5 million years ago. We'd never planned to work on those. You cannot relate those sections. I'll show you some of them, except by primary geochronology. It's the only way you can find out how old they are, because they don't link. Each one is its own little system. But by contrast, the Pliocene and the Pleistocene deposits are one of the largest fluvio-lacustrine systems that has ever been investigated on this planet. Okay? And we link those together by volcanic ash layers, and I'll say something about that. The same volcanic ash layers link to other places in Africa, and I'll give you some idea of the scale that we work at. Basically, it's on the thousands of kilometer scale that we can link things through. So, to run over really quickly, here are the Mursi people, the lady, oops, I want to go back. That's not supposed to do that, but that's all right. They have these big lip plugs. It's one of the few tribes that do. You see all the ladies have those big lip plugs. We don't know why, but the Turkana who see these think they're horrible. If you look at the language groups, there should be one more on here, and it's probably going to come in on a click, and I thought I got rid of all of those. These are Gabra people over here. These language groups, the Cushitic, the Omotic, the Surmic, and the Nilotic, are as different as Chinese and Japanese and Romance and Germanic, if you like. These are really different people. They have really different customs, and wherever they border on each other, they don't like each other, and they steal each other's cows, and that's particularly the biggest reason they don't like each other. Okay? But they're absolutely wonderful people to work with once you get to know them. Okay? Now, getting there used to be hard. It's easy now. You can drive down to the Omo in 2 days, all right? The first time I went, well, it took a couple weeks, but that's because you couldn't get petrol for 400 miles. You had to go 400 miles south to get it, and so you had it shipped up on a truck. We could use a ferry that the Russians built, but every year we had to repair it. We had to bring a welder down and repair the ferry, or you could take this road getting into the Omo Valley. It wasn't too well used. And then when you get down off of the highlands here, where there was some decent drainage, it sometimes got a little muddy. This is 2004, right, Terry? 2004, December. It never rains in December. That's what I told Terry, so we went down there, and I guess I was wrong. So, anyway, that's comic relief, yes. This area is where we work. It lies at low elevation, about 450 meters, 1,500 feet roughly, above sea level. Turi will tell you that it's the hottest 1% of the land surface of the Earth. It's hot down there. It has very low rainfall, okay? Vegetation is sparse, but it's very diverse. Just a couple years ago, I worked with a botanist from the herbarium, and if you had looked at the literature on Turkana, on the east side, there were 84 taxa known. That's as many plants as existed there. We spent a total of about 4 weeks collecting, and there are now 400 taxa there. Right? So it's hard to get to. Right? It's related to the rift, but it's not in the rift. Okay, and this last point here, it shares a drainage divide with the Nile. That will come to be important later in the lecture. Now, how are we doing? We're doing all right. Now, I've tried putting the outline of Utah on, and people couldn't quite still understand the scale. So this time what I did is put I-80 and I-15 on at the same scale. So that's Salt Lake and that's Wendover, all right? That's Salt Lake City and that's Cedar City with Beaver and Fillmore and Provo on to give you some idea of the scale. If you wanted to, you know, if you were up here and you wanted to work at Canapoy, you would have to drive the equivalent of driving to Cedar City. Now you would think, oh, well, that's a couple hours, right? Maybe you could do it in 4 hours. Probably closer to 3 days. The roads aren't particularly good there. Now, also, many people have said, well, why on earth have you worked for 50 years in this place? You should be able to work a little bit faster than that and get it done. And how long have people worked at Olduvai? The Leakeys worked for 30 years at Olduvai before they found a hominid. This is the size of Olduvai at the same scale, all right? And this is the size of all of the wonderful things that you hear from Tim White and Don Johansson with Hadar at the north and Buri at the south. That's the next biggest place in East Africa that has fossiliferous deposits, but it's tiny compared to the territory that you've got to get over in Turkana. Now, as far as serendipity goes, this is kind of, I'll keep it short, but I worked here. Clark sent me to do a stratigraphy, and I got about 2/3 of the Shungura Formation measured in 2 months in 1966. And then all of those old guys, Ehrenberg and Clark and Louis Leakey, flew over in an airplane, and Ehrenberg looked out the window and he said, that's where I worked in 1930, that's mine. And that is exactly where I worked, all right? And then they flew north and they said, oh, there are more exposures up here. I'd already seen those. I knew they were very young, but they didn't know they were young, so they said, fine. Clark says, I'll take the west side of the river, you take the east side of the river. So, in 1967, we were banished. We were up here. Now, if we hadn't been banished, we never would have found that little spot. And these are young, but that is old. And Clark was the head of the expedition. He was really depressed. And he said, you know, there's got to be something older around here. And one afternoon, there was a guy named Lynn Fichter, a paleontologist who was with us. I said, well, there's that little hill down there. Why don't we just drive down there and see what it is? And we drove down, and you come to the edge of the outcrops, tiny, not much, probably twice the size of this building is all. But you couldn't walk on it. There were so many bones on the surface. And they turned out to be about 3.2 million years old, and they were full of hominid teeth. So Clark was very happy with that. But at the same time, Richard Leakey was working up here in Kibish, and he found a skeleton of Homo sapiens, and it now turns out that's the oldest skeleton of Homo sapiens that we have. And we'll come to that in a little bit, all right? Well, then I worked here until 1974. 1974, the government of Haile Selassie fell, and there's where the politics comes in. And basically, no one got into this area except for 2 brief excursions by a student and myself. They were probably stupid. In 1985-86, when the Derg was in power in Ethiopia, we had a heck of a time getting in, heck of a time getting out, all right? Then in 1980, Richard asked me to look at this area to help him out with his stratigraphy, Richard Leakey. And that was a big task. It's a big place, Kubifora. We're still working on it now. Just a couple years ago, I finally put this piece of section in place, and last year a little bit of section south of that. But then in 1981, he said, you know, there's some things on the west side. I want you to look at those too, all right? And so I started looking at those, and then in 85, because of the oil exploration, they flew me over to various places, and I looked at this spot here, and I said, gee, Richard, you know, it's full of fossils of all kinds with fossil wood and leaves and mammals, and so that was Lothodoc, so we had to, that's Miocene, we had to work that. And then when we were at Lothodoc, Richard said, you know, there are some things west of you, and we looked at those, and those were Pliocene again, and we have those. And then in 2006, I really wanted to find the edge. Where's the end? Where can I stop before I croak, right? And so I spent quite a bit of time running around finding the edges of the depositional basin. This one is a different one, and I'll explain why we started looking down there when we go through some things about the tuffs, all right? So all of these places come about for serendipitous reasons. You go to do one thing, and you end up doing something else. To give you a couple of images of what the basin is like right now, the modern environments are strongly controlled by water. Water is everything in that country. It's the same as the Nile. If any of you have ever flown down the Nile Valley, you know that it's a green snake going down through buff-colored sands on either side. What's important here for thinking about reconstructions of ancient mammalian communities is that when animals die, they often get picked up in the river, but they may live in rather dry bush on this side of the river or in gallery forest on this side of the river. So you get a mixture of creatures instead of getting a nice clear signal, this is a forest, or this is a grassland, or this is bushland. And that's something that Terry, I've warned him, you really should have him give a talk here again on the wonderful things he does with isotopes. All right, so you're on next year. All right. Oops, that's not what I want to do. All right, so if you go up to the Omo Valley, it's wetter than it is farther south, so you have grasslands. You get down to the south end of the lake, and you have these dwarf shrublands with very little covering the land surface. All right. Okay. Well, what pays the bills? What we went to look for were these, and this is not my job. This is the job of the paleontologists and the anthropologists. They go out and look for these bones. My job is trying to figure out how old are those bones, and to some extent, what is the environment in which they were deposited. Well, these are some of them. All of these come from the Turkana Basin, and I'll sum it up again at the end. But there are since 1962 with Homo habilis, there have been 15 new sorts of early man described in the scientific literature. 5 of those come from the Turkana Basin. All right. And I think that's pretty good. There are a lot I could have used, as Richard does, Richard Leakey, all covers of nature for essentially all of these. All right. Well, the search for early humans led to a great deal more. All right. The only known Cretaceous dinosaurs in East Africa. All right. Late Oligocene mammals. Okay, known, and some of these known only from Fayum in Egypt until about 10 years ago. And then new primates, new genera of primates in strata between 13 and 25 million years old. Okay? So, this is the Labor Range. These deposits up here, it's a big sandy conglomerate sequence, and at the base of that, Mark Lowen is here, he has been there. At the base of that, you get sparse dinosaur bones. Again, serendipity intervenes. People had driven past this for years. It was mapped as Miocene, and we got stuck because we couldn't get across a muddy spot with our trucks, and so we camped where there was water at Logiton Gorge. In the evening, Jerry Eck and I took a walk, and here's this Sauropod Humerus. All right, it had to be a dinosaur. We collected it, but we didn't have a collecting permit in Kenya, and the politics comes in. The survey was furious. We gave it to the museum. The survey said it can't be a dinosaur because these are Miocene deposits. And we said, well, it can't be Miocene deposits because that's a dinosaur. All right? Finally, Ehrenberg was wonderful there. He simply published that this is a Sauropod humerus, and that put things to rest. All right? This is what they look like. Terrible, terrible rocks to work in, not much variety. All right? Well, then if you move to the younger rocks, you see all of these, the purple ones. Well, first of all, these are Pan-African metamorphics in East Africa. They're about 500 million years old, perhaps a little bit more. And then there's nothing in the record, okay, until you get to these purple ones. And the oldest ones of those are here and here. Here they are 36 million years old. They're the oldest volcanic rocks that we have in Kenya, and they're telling us that the crust is beginning to stretch, all right? Farther south, actually, there's a big fault that goes through here, and it chops off Oligocene rocks in the north, and then way in the south from Miocene rocks here in the middle. And this is the spot that that tiny little thing right there is full of fossils, and that's where Turkanapithecus and Afropithecus come from. These were unknown until 1985. The green is the Cretaceous, maybe. Nobody's ever found anything to prove that this is Cretaceous, but it looks like these sediments. Well, we ended up doing a lot of reconnaissance work and basically dating all of these lavas as well, but that was really an aside from it wasn't what we were supposed to be doing. We were supposed to be working on the Pleistocene, all right? Here's what they look like. This is Lothodoc Peak. It's hardly a peak. You'd call it a bump if you were here in Utah. But it has these wonderful Oligocene strata underneath. And then farther south, I just put in the dikes so you can see them. We have these sediments that are cut by basaltic dikes. They're also Oligocene. And because this site near Loperat, Nakwai is one of them, you have things that we haven't seen anywhere in the world except in Fayum, which is up right outside of Cairo. So this extends the known range of these fossil animals by 3,000 kilometers to the south. So that's, you get all sorts of surprises when you start looking at things on the ground, all right? Right now, well, you'll see more pictures of the general area. It's dry. There are no big trees there. There are acacia trees. You sit under the acacia trees. If you can't find an acacia tree, you find an acacia bush. And even the slightest bit of shade helps you tremendously. And I tell the students that, don't sit in the sun. Always sit in even partial shade, and you can last a lot longer. But in the Miocene, up until about 13 million years ago, everywhere you look in the Miocene, you have these gigantic logs. So this was a time when that country was forested. And exactly what happens to change that, I don't think we know yet. But that's probably why in the Miocene we find fossils of apes. Almost no monkeys, but we find apes, ape fossils in these forests, all right? So here, I know you can't read it, I just put where there were fossils that needed dating in various places. Locharangon, you saw those plants going by at the beginning. I was looking at a piece of Pleistocene section with a student, William Anyonge, and there was this little plant over there. I said, "Oh, William, come look at this. This is Jatrophophis spina." And we went over to look at, and underneath it were these magnificent Miocene fossils, 17.5 million years old. And so, again, serendipity. You're doing one thing, and you find something else. About the only good fossils in this age range, and notice the thickness here. In order to build up these sections, you have to measure kilometers of section. They're thousands of meters thick, these volcanic sections, so it takes time. These are the only good late Miocene faunas known in East Africa, the good faunas. There are bits and pieces from other places, but not very much, okay? All right, so here, this is the only known late Miocene stuff. Spectacular place, Lothagam. Absolutely beautiful, no water. You have to haul water in order to work there, right? Okay, well those older rocks, those Miocene rocks, we're doing okay. I'm trying to watch time because I tend to blather on too long about things and run over the students. Some of the students are here from class. They know that I commonly go over in lecture. I don't mean to, but they're paying for it, so they might as well get their money's worth, right? So these older rocks are faulted, okay, and there's the fault. They're in fault contact with the younger rocks, and here are some of the basalt flows that are turned over right along that fault. This happens about 4.5 million years ago, not much older than that. And we know that from what we call paleomagnetic polarity stratigraphy. And at first you get a bunch of lake beds, okay? And the lake beds run up to about 100, 120 meters thick maximum. And then about between 4 and 4.2, but very close to 4.05 million years, you have basalt volcanism essentially over the whole basin, and then it stops. And we have no more volcanics there until recently in the local area. Well, these things, those are columnar basalts. Simon is about 5'6", to give you an idea of the size of those things. These are absolutely wonderful because they're seismic reflectors, and this gives us a 4 million year old datum to look at, and we can look at how much sediment is above that. We'll come to that a bit later in the talk. What number am I on here? Oh, I better move. Yeah, they're all the same chemically too. All right. See how fast we can move? This is where I started work. This is the Shingura Formation. You drive and you drive and you drive 3 days. 3 days up there, you whack your way through bush to get there, and you come out upon these absolutely magnificent deposits. And I think, in some way, I fell in love with that particular chunk of territory back in 1966, and it's never gotten any weaker. I still love seeing those places. And I had almost no petrol. I had to have petrol to get back to Nairobi. So the only thing I could do to do all of the field work was walk. The car sat. And I can still walk back to almost every place in that formation that I saw, and it's about 40 kilometers long, so you get an idea of the size. Well, these are the sorts of things. It's a trove of mammalian fossils. There are greater than 60,000 specimens from the Shingura itself. If you add the ones from Kubifora and from Lothagam and from the Nachukui Formation, we must be looking now at well over 100,000, guess, Terry? Well over 100,000 fossil vertebrate specimens. It's a magnificent set of things, and some of these things, these fossils, give us temporal information, even if we're not sure of the ages. And what happened early on, it was a big controversy back in the 1970s, is that we had dated the section north of the lake, and Richard Leakey had people, Fitch and Miller, dating things east of the lake, and there were two different chronologies. Now, that's okay, they're in two different places, but if you looked at the pigs from those, the pig teeth are, where'd it go? There it is. Pig teeth are huge, and you can measure, here's their length in millimeters, okay? And if the ones from the Shingura Formation north of the lake are all of these, all right? And those are the ages that we put on these. This is 1972. We've changed them slightly now, but not very much. This was a pig associated with an early hominid, 1470, which is now Homo rudolfensis, that was thought to be 2.6 million years old, and we said, no, it ought to be closer to 1.9. There was a paper published a couple of years ago that says that it's 2.0, all right? So the pigs don't lie, and in the 70s there was this wonderful phrase, male chauvinist pig, all right? And there used to be neckties that you could have that said MCP on them, all right? And Basil Cook, one of the authors of this, always wore his MCP tie because he said it means that Mesochurus correlates properly, all right? People have good senses of humor. You can do the same thing with the elephants, you get the same answer, all right? Well, the break came when this guy, Serling, came up to visit me in 1976, I think it was, because I was pretty sure our chronology was right. We got more dates. And Terry and I said, well, what if we could correlate the volcanic ashes? And Terry said, well, I've got some from the east side of the lake. And I said, well, I've got stacks of them from the north side of the lake. And so we started looking at the chemistry, the composition of these, chemical composition of these ashes, and by gosh, you can tell them apart. It doesn't do any good to go and look at them in the field in a sense. That one's 5 meters thick. That's the Chari tuff. It's about 1.38 million years old. This little wimpy thing here is about 20 centimeters thick. Both of them have big pummices in them, all right? Now, I should probably explain why we need the pummices. If you want to date one of these ashes, you can't just take a bag full of the ash because it will have detrital minerals in it, and those detrital minerals will be either 500 million years old or something like 20 million years old or 30 million years old, and you certainly don't want to get those mixed up, all right? But if you have a pumice clast, okay, pumices are the things you use to scrub your feet, okay? If you go to the store, they're good for scrubbing your toilets too. If you don't know it, that's what the plumbers use here to get the hard calcium carbonate off of your porcelain. Okay, well the pumices are intact. You can cut off the outsides, and you have a piece of that original volcanic material with no contamination. Okay, and that was the importance of the pumices. But the point here is it doesn't do you any good to simply look at them because the same tuff looks different in different places. Different tuffs look the same in different places, and almost all of them look pretty much the same anywhere. They're almost all gray, and they're all sort of 20 centimeters to a couple meters thick. You can't tell them apart in the field. Well, Turi started this, and he said, well, we could look at the shapes of the shards, and that's fine, but you're limited by the variety of shapes, okay? These two, you might say, came from the same ash, but you certainly wouldn't say that that one came from the same ash. So you could tell things apart, but you couldn't be too sure that they were the same, okay? And in fact, lots of the ashes have this sort of glass shard morphology. These are just, I tell the students in class, if you want to see what these look like, put a little bit of detergent in a cup and put a straw in it and blow bubbles. And all that foam that comes up are exactly these shapes, all right? They're bubble junctions, okay? Here, the bubbles never coalesce, so those are little bits of micro pumice, all right? And here's what the shards look like in a rather young tuff, this one, and as you get to older and older things, they get more and more rotten until they turn into clay, and then you can't use them anymore. So we're really dependent on having the glass. The reason we need the glass is that's the one thing we can be sure is primary and associated with an eruption. Okay? Yeah, we can go forward. Boy, it's getting late. All sorts of deposition. These I really like, because these are what are called accretionary, the pili. They're what happens when an ash falls through a rainstorm. And the ash particles get wet, and they're just like hailstones. They keep getting bigger and bigger. They land, sometimes they flatten a little bit when they land, but if you pick them up with your fingers now, you crush them. Those have never moved since they were deposited. That particular one is 3.6 million years old, all right? I best move it here, all right? Here's Turi, when he had more hair, okay? And he's standing at the bottom of one of these tuffs. We call them tuffs, but they're really volcanic sandstones in many cases. These are huge anti-dunes in the bottom of a big river, and the top of this particular tuff is up there, all right? Now, if you look at the crossbeds of this thing, they are running into a wall of rock, all right? So you had a channel 16 meters deep, a river that was 16 meters deep. It was heading into a faulted piece, but that had to exist somewhere to the south, and that's the reason that I went south with a student and looked for things around Loingolani, right? Here, there are pumice gravels in places. To very, very quickly, and you could do a whole lecture on this, but if you look at a bunch of the different tuffs, this is a plot of the iron content versus niobium content. They're all different, okay? You can tell them apart compositionally. You can recognize them, all right? It's kind of, yeah, they're recognizable that way. Well, the feldspars and the pumice gives you dates. The glass in the tuffs lets you lets you identify particular tufts, and volcanic events are very short. So basically we're looking at single lines in time going across this basin, all right? In some places you have tufts that trap alluvial fans. In other places, it may be a different time, these are 1.8 million years about, you have high energy beaches, all right? Other places you have muddy calm waters with clams living in them. These are clam burrows, some of the lochia. And then you have faults. This whole thing is faulted by several, across the width of the deposits, it's faulted by a couple kilometers. So if you were to collect a fossil from this side of this fault, it would be 1.3 million years old. And if you got it from this side of the fault, it would be 2.4 million years old. So you have to map the faults as well. All right? Now these I'll come back to very briefly later. These horrible things are what this guy likes, all right? They're terrible things to describe, all right? Okay, well the primary age control is by and large, and I could tell you the serendipity story, by and large the work of this guy, Ian McDougall, who has really written the book on argon 4039 dating, all right? It used to be that we would need a vial full of that to get one age, full of feldspars. And now you could take any one of those grains and get an age out of it. So you can do them in 10 minutes once you have the thing set up. You used to take if you get a date a day, you were doing well. All right, it's absolutely amazing what's happened technologically, and it makes things good for us. So I only had 10 minutes. Now I was going to say something about kind of how science works. In 1871, Darwin said that early man should be found in East Africa. And the Dutch said, no, that's nonsense. It must be in the Dutch East Indies, because we own that, right? And Dubois went there and found Pithecanthropus, or Homo erectus now, in 1888, all right? Well, also in 1888, Taliki found Lake Turkana. The local people didn't know it was there until we told them, you know? And then Boisei went there in 1902. He didn't come back with much, died on the way. Then Dart in 1924. This really set South Africa up. It's one of those singular events. He found the tongue skull. He said the foramen magnum is oriented downward, so this must be a bipedal creature, and this is an early man. He called it Australopithecus, all right? And Australopithecus africanus. Well, and so nothing happens for a long time, okay? And then Ehrenberg went up, found all this stuff in the Shungura, but no early man. Then there was this physicist, of all things. I mean, it's terrible for geologists to have to depend on physicists, but this guy was actually interested in the composition of the atmosphere. And he said there is too much argon in the Earth's atmosphere, and it must come from decay of an element on either side of argon. There isn't enough chlorine, so it must be potassium. We don't know that there is an isotope potassium-40, but there must be because of the argon-40 in the atmosphere. We don't know about this decay mode, but it must exist to give you argon, and he was right on all counts. Well, that was 1938. Now, poor old von Weizsäcker was in Germany. Now, does politics matter in 1938 in Germany? Oh, yes, right. So that's where the politics comes in, all right? Well, then it's not until 1959 that Leakey finds Zinj, and then way over here, Curtis, Emmett, and Reynolds in 1960 date this thing at 1.75 million years. So all of these little threads of science from different places, the composition of the atmosphere, the ideas about evolution, all come together, right? Well, here's another thing where the fossils help us, but this time it's the fossils in the ocean, all right? And we had problems with the age of Lucy. You've all heard of Lucy. She's famous. Australopithecus afarensis. You've all heard of Lucy. She was supposed to be over 3.5 million years old. And I happened to read a thesis one night for Bob Walter, and I looked at that thing and I said, I know this tuff. This is the Tullibor tuff. And I wrote to them and got a sample of it, And it's the only time I've ever written a paper before having the data in hand. I was so sure their data were good, and indeed they correlate. So Lucy was less than 3.4 million years, and in fact is closer to 3 million years if you want Lucy herself. Well, we didn't know the age of that tuff in the beginning, but I found it in a deep sea core which had been preserved from the deep sea drilling project out in San Diego, okay? And we knew the calcareous nanoplankton. These are these little guys, tiny little things, all right, horrible things to work on. But Peter Roth here was an expert on those, and he said, okay, well, we can place that at just about 3.5 million years. And so we were set, okay? Now, 8 minutes. The dust load from the continents gives you it tells you when things are wet and dry. Right now it's dry, so lots of dust is going into the oceans. You see it in the satellite images, all right? Well, the oceans have been recording that for the last 14 million years, okay? And the way they record it, it happens every 20,000 years. Things get wet, things get dry, things get wet, things get dry. So if you want to know the age of a volcanic ash, all you have to do is count these peaks. You go 20, 40, 60, 80, 100,000, 20, 40, 60, 80, 200,000, all the way down to 3.4 million. These are ages that we got out of the deep sea before we had ages on land on these. And this is now dated at 3.6, and we picked it at 3.58. We thought this one was 3.7, but it's 3.62. This one, we had 3 ages on and didn't know which one was right. It's now dated at 3.97 plus or minus 0.03. We picked it back in 92 at 3.96. So we're good to about 10,000 years and 4 million. And that's good. So there's another way that you can get at time, all right? Now to give you some, this is Baringo. This is a section at Kipchireri. This is about 200 kilometers south, and there are 2 of these tuffs, one here and one here. These have to be airfall tuffs, and they cover a good chunk of territory because we have them right in this section, 500 kilometers north-south, all right? And then if you look at what you have with the deep sea cores and going out to the western rift, where we also have them, these things are spread over subcontinental dimensions, 2,500 kilometers, all right? If you put the west end here, this is somewhere around Columbus, Ohio, okay? So if that's Salt Lake, that's Ohio, all right? We can also do paleomag, and I'm not going to belabor this, so I want to get through it quickly. Here are the ages, here's the age control now, and those are the plus and minuses are inside those circles, all right? So we have control on all of this. That's a piece I would like to fill in, okay? That's a piece I would like to fill in. But it's the best controlled section in East Africa. This means that, for example, we can look at lake deposits here. We find out they're very short, about 100,000 years. Over here, they run through several 100,000 years on the east side of on the west side of the lake, and the same on the east side of the lake. This tells you something about how the basin is deforming through time. I said I would come back to these horrible things that Turi likes. These are the paleosols, the ancient soils. And what is absolutely wonderful, Turi and one of the best students we've ever put out of this university, Ben Passy, who's now at Michigan, figured out a way to get paleotemperature out of those soils. And what we learned from this, and this is one of the most important things Turi has done, I think, is showed that the red line is the maximum soil temperature at Illeret now. And we did this by burying little temperature recorders, all right? This is the mean soil temperature, okay, at 50 centimeters, okay, and that's the minimum soil temperature at 50 centimeters depth. Now, the ages, I can put on all of their fossil soils. You put this together, and you see that it's been hot there for the last 4 million years. It's been as hot as it is now, or hotter in times. Now that means if you're going to change the vegetation, you can't ask you can't have nice, cool, dry periods. No, you're going to have hot, dry periods or hot, wet periods. So it's got to be precipitation that is changing in the area. Okay. If you look at how we put these things together in time, I'm going to make it. No, I'm not. Oh, I got lots more. We'll just stop. If you look at how these fit together in time, that's just putting all of the Australopithecus in this. Here's Kamoyapithecus. But one of the things to notice is that many times in the past, there was more than one kind of creature kind of like us. None of them were us yet, okay? But they were kind of like us. And today, there's only one left, and that's us. The last one drops out about 30 some odd thousand years ago, 38,000. That's Neanderthal. And Neanderthal, when moderns come out of Africa, Neanderthals disappear fairly quickly for one reason or another. But for a long time, we could coexist. We don't want to coexist anymore, I don't think. To give you an idea of sexual dimorphism, that's probably what this is. That shape is the same as the shape underneath. This is probably female. That is probably male, okay? Those are probably Homo erectus, okay? That one is supposed to be descended from Homo habilis, but these fragments of Homo habilis, okay, are 1,000 years younger than those. So either those two were contemporaries, or they've got the relationship backwards, which is how time helps you out with. Come on. All right. Yeah, you guys can wait. Let's see. If you look at the younger part, this is the Kibish Formation. What's important here is that when we all got banished north in 1967, Richard Leakey found, with his team, found this skeleton of Homo sapiens, all right? At the time, people thought it might be as much as 30,000 years old. Now look at that one thing there. We tried to get money to go back. People said, no, you'll never find the place that it was picked up. But John Flegel asked me to take him there, and I did. And John picked up that bone. That was collected in 2001, and it fits on the bones that were collected in 1967. We have the right place, all right? There's no question about that. Now, here we can use what's happening climatically in a different way, okay? Because when rainfall is high in East Africa, this is what Lake Turkana looks like. It can't get any higher because here it flows out to the Nile, okay? Now, I said before that the drainage divide is in common between the Nile River and the Omo River that feeds Lake Turkana, all right? So what happens to the Omo must happen to the Nile. So when you got lots of water filling up this lake in Turkana, you should have lots of water going down to Egypt and running out into the Mediterranean. And when that happens, you put a freshwater lid over the eastern part of the Mediterranean, the bottom goes anoxic, and you preserve organic carbon. And you see, the Europeans have known this forever, okay? Come on, all right? What we have in Kibish, we only can get deposition up here when the lake is high, all right? And you can see this. That's an old, in the field, that's an old hill, all right? That's overlain by member 3. You don't see this member 2 being disconformal in this. Go a few hills away and you will see that it is, okay? Well, here are those, I put 3 yellow dots there. Those are things called sapropels. Those are the organic rich layers. Otherwise, the deep sea sediment looks kind of like vanilla ice cream, all right? And so you can see that just going down in the core, these are coming with regularity, all right? And this is cyclicity, all right? And you get one of these every time there is high rainfall in East Africa, because here's the Nile River Basin, right there is the divide going right through there. This comes down into Lake Turkana. All of this goes down into the Nile. Some of you may have seen we'll just skip through that right now. All right, what we did, we found 3 things that we could date. This tuff at 196,000 years, this one at 104, and mollusks at about 10,000 years, okay? Now, those correspond precisely with the ages of the sapropels in the Mediterranean, and we had 2 periods of deposition in between. 124,000 years is a sapropel. We said that's where that belongs, and that's 172,000 years, said we. Well, this actually correlates with a tuff that's dated at 180 plus or minus 5,000 years. If you want to make it 180, that's fine with me, because what it does is confirm this age. The early skeleton is down here. It's 196,000 years old, give or take a little bit. All right? It's the oldest Homo sapiens we know. Now, I told you about this basalt, this purple basalt over here. It's seen seismically in all of these places. This is what we would think, 1,000 meters is what we thought we had for a section. And Terry and I even worked up the sediment balance on that basis. Then they started doing this. And then with gravity, we find that even up in the Shungura is the thickest chunk of section, but on either side of it, the section is 4 times as thick. If you were to draw this basin, it's an absolutely beautiful steer's head that we didn't know existed before. So the geophysics comes into it. We also learned that these surfaces can have an immense amount of time on them. On this one, there's a 1.3 million years. We know that from the volcanic ashes above and below. This is something that I thought I was going to be very clever and prove, and I got even cleverer and disproved my brilliant idea. I thought that because we had 100,000 years between these two tuffs, and this keeps happening, and you get 5 floodplains stacked in between, those floodplains must be controlled by this 20,000 year periodicity. But if you look at the volcanic ashes in each of those floodplains in one section, they're not the same ashes that are in 5 floodplains in a different section. So that was a large waste of time on my part. Okay? Don't tell the dean. All right? Okay, and then this is the last one, I think, except for summary slides. But you have to also, we talk about these millions of years and hundreds of thousands of years and tens of thousands of years, but this is what can happen in 16 years. All of this area here is lake in 1973. And in 1989, it's all delta. So we have to keep this in mind when we're trying to reconstruct ancient environments in the region, all right? And then this is just a quick one to give you an idea how many places that Turkana correlates to. And this goes back to a talk that Clark and I had in 1972. Plate tectonics was just getting going, all right? The deep sea drilling stuff was just getting going in a sense. And Clark and I sat there in the Omo and said, you know, one of these days we will be able to use this oceanic stuff to say something about what's going on land. And it's really nice, it's taken 50 years, but it's really nice that that's actually happened, you know? There's an immense amount of satisfaction in science. So, we have the only Cretaceous dinosaurs, we've got early primates, we've got the thickest and most circulated sequence in East Africa. It's the source of 5 of the 15, I call them early relatives, named since 1964. Okay, the most complete skeleton of Homo ergaster that's known, that's on display, or a cast of it is, up in the Sutton building, if you haven't seen it. Okay, it's the source of the oldest anatomically modern Homo sapiens yet known, with over 100,000 fossil mammal specimens. It means that if you don't have anything to date in a place, you can look at the mammals that are precisely dated in the Turkana Basin, and you can find out how old your deposits are anyway. Okay, and then all of this, it lets us look at most of our sites in a single temporal framework, all right? So that you can't get away with saying, oh, well, this guy must be ancestral to that because this looks more primitive than that, if the age relation is opposite, right? You got to have things in the right order. We know the ages with high precision. We still don't understand how they're related. And that's really a task for the anthropologists. And through the past 4 million years, lots, sometimes 3 or 4, different kinds of early human-like creatures were living in the same place, okay? We can work on the environments easily, okay? Early tools, at least 2.3 million years in the basin, tell us that technology was beginning, okay? And they may be 3.3 million years old. Someone will say, why don't you believe it? Oh, because I haven't been there to see it. And actually, I'm not sure. I'm sure of the age of those strata. Whether the tools are in situ, I'm not yet convinced, okay? We don't know who made them. Certainly they occur before the appearance of the genus Homo. And that really complicates things. If the first tools came with the first appearance of Homo, all right, then we can say, oh, obviously, Homo evolves and starts making tools, all right, and then makes computers in the end. Well, it's a little more complicated story than that, but that's basically the idea. If we have tools before there is the genus Homo, then somebody else could do it too, right? And there's no reason that they shouldn't have been able to, all right? So that's the end of the talk. It's a bit over. I apologize, all right? This is how we used to get across the river. You can take a regular old boat now with a motor on it, okay? But this is 2000, when is it, Terry? 2008 or 11? 2008, yeah. This is how you got across the river. Terry was lucky. He left one day before me. He left one day before me. We had two cars on the west side of the river that were rented cars, and they had to get back to Addis. And it rained like hell. In the highlands, the river came up 8 meters, ripped out the barge that had taken the cars across. Terry was happily on his way to Addis by that time. And we were stuck with two cars on the wrong side of the river. And you can't use that little used road if it's rain, because that's where the water comes from. So we ended up driving 1,400 kilometers around the entire lake to get across the river. So anyway, thank you for listening, and
And I'm sure Frank is willing to answer questions. He's been doing it here at the university for many years, and he's...
Oh, and if I don't know the answer, I'll give you alternative facts, okay? Actually, where's that? This is the biggest alternative fact I've ever seen. I didn't know you guys learned so quickly from Donald Trump. This says that I want my money, damn it. I'm a 5-time winner of the university's Outstanding Teaching Award. I've never gotten the Outstanding Teaching Award. I've gotten the College Teaching Award. I've gotten the Departmental Teaching Awards a whole bunch of times. I've never been the Outstanding Teaching Award for the university. John Bowman is. That's an alternative fact. Keep repeating it and it will become true. Are there any questions? I'm happy to answer anything. Yeah?
How far north of the equator?
5 degrees, about. It goes, the southernmost piece is about 2.7 degrees north, and the northernmost piece, it depends where you take it, but it's not quite 6 degrees. Okay? Yeah?
Is the lake brackish with water or is it still fresh?
The lake? No, the lake you can't drink. The lake it's just on the edge of being drinkable. If you get up to the north end, it's fresh enough, but the south end, no. And it's a sodium carbonate lake, not a sodium chloride lake. So it's saline. A bunch of people capsized from the Kenya Wildlife Services a few years ago. It's alkaline enough that if you're in the water for hours, it'll take your skin off. And so they arrived on the beach very nearly flayed. Yeah? What's next? I think the next thing that I should probably do is quit going to the field and write up what I've got. But I have a very hard time doing that because every time I start writing something up, I come up with 62 more questions that could be answered easily with one more field season. Yeah. Rich?
Would the fission track dating do any good to help in dating those?
It didn't. It didn't. It's not nearly as precise as Argon 4039. Argon 4039 is now, if you're really squeezing it, you can be within about 0.2% of the age itself. And fission track, you're still looking at sort of 5%. Okay.
So what would be the age ranges on fission?
Oh, you can use it, and it has been used there. It's just, the ages fit, but they're sloppier. And what we want is really tight ages. Now, someone has asked me, what good does it do you to know exactly how old each of these ashes is that brackets the fossils in between them if you don't know the relationships between the fossils? Well, I'm not quite sure how to answer that. All we can do as geologists is give you the best numbers we can give you, and eventually you will have enough fossils to figure out the relationships between these different taxa. And I don't see that because we don't know the relationships is a reason to relax the care that we take in getting the dates of the highest precision that we can get. Yeah?
You speculate on the likelihood of finding an older than 196,000-year-old Homo sapien?
I might be able to speculate on that next week. I would think, yeah, possibly. Yeah. As soon as the microprobe is fixed, I'll be able to tell you. We tend not to speculate too much. It's much better to make your announcements once you have the facts in the bag and all the T's crossed and the I's dotted and everything nicely in order. Too much happens, especially these days in science. It's something I don't like. Everything that comes out, you read Nature, read Science, look at the NSF bulletins. Everything is the greatest or the biggest or the oldest or the newest. It's always something superlative. And we need to get rid of this EST ending on things. These are this old. And one of the things that was absolutely wonderful about working with Clark Howell, as opposed to working with many other anthropologists, was that Clark didn't care how old something was. He wanted to know how old it was. If you said it was 1.8 million years and someone else said something at 2.4, that's fine. And if you told him you had something at 2.6 and somebody else said something, that's fine. He just wanted to know, how old is it? And he even said that. He said, I don't care how old it is, I want to know how old it is. So he was a wonderful mentor to me. Anybody else? Thank you very much. Oh, is this running again? Oh.